Okay. Okay, I still don't get it how it works this. I mean, it's kind of doing some strange things and with the emission and then connecting to the public, and it's a nightmare. Every time that I try to start a new emission for a new live class, I got some different problems, you know. So I don't know. So the thing that we are going to do in order to have solved this problem is to have a setup that is fixed in one place, and it's going to be on the next week. Okay, so from the next week we are going to have a fixed place and everything set up, so we don't have to deal with those stupid things. But anyway, so hello ROS developers, welcome to a new live class. I hope that you are ready, because today we are going to work with ROS controllers, and that's always a complex subject there. It's a difficult subject, but we'll try to make it very easy. Okay, so this class is about how to detect when you have a problem in your controller. So you have an armed robot, something similar, that is using controllers, but it doesn't work. Then what is the process of debugging in order to find where is the problem? So that's what we are going to see here, very step by step. Then let me say hello to the people that is here. The first one to arrive was Gloria de Felix from San Francisco, California. Super hello for you. So Gloria and I, we met sometime that I was in San Francisco, so we met in person. I'm super nice that you are here back. Also, we have Ter Caput, that I don't know him in person, but he is always here on the live class and asking questions and putting me in very difficult situations when he asks very important questions, you know, that I don't know how to answer. But yes, very good. So more people here come in. It's Hirak Yoti Basumatari. Hello, nice to meet you. It was difficult for me to explain to say your name, but it's my pleasure to have you here. RZ is here again. Also Matthew Hinton. Also very cool that you are here back. I don't remember you were on the last one, but you've been in many classes and follower of our videos. So hello, Matthew. Then Pradeep Bena, also hello. Nice to meet you here. Kaulat Ayomide also. And many other people that are there just waiting to start a live class. So guys, let's start and let's start working. So how we are going to work here today, as always. So let me explain for the new people, okay? So I have prepared together with Christian. So most of the job was made by Christian. So Christian is the intern at the Construct, and he has created together with me a notebook, a ROS, some code, some simulations. So we have created all this stuff, and we are going to share this with you so you can follow the live class here today. And everything is provided for free. Okay, so don't worry. So what I'm going to do is to share a link now there on the chat, and you are going to get all the code and notebooks and everything that we are going to use here today in this live class. So by clicking on that link, it's going to lead you to the ROS Development Studio, and there you will have a free account that it's free, it's enough, and then you will get all this project, what we call a ROS project containing all this material. Then you're going to open it and you are going to follow the steps as I do. Don't worry, don't get overwhelmed. I'm going to show you how to do that on my own screen there. Then let me say some more people here. So Hirak Yoti says, you said correctly. Thank you very much. Thank you. Very good. Peter Bokuti also, his first time here. So please everybody say hello to Peter, his first time at the live class. And then we have Christian that, Christian. So he's saying hi everyone. Christian is the guy. He's the man. So you should also say hi to him. So let's go, guys. Let's go, because I don't want to finish late, as I always do. I presume that you have many things to do. And then let me go. First thing, I'm going to share with you my screen so you can see what I am doing, and then you can see my screen on the bottom, but it's very small. So let me share full screen here and put here, you know, the ROS Development Studio. Okay, great. So that's the ROS jet that you are going to open in a minute. Okay, so here are all the material that we are going to follow today. But before doing that, let me go here to my list of ROS jets and show you the ROS jet that we have prepared for today, this one here. And now I'm going to share it with you by clicking on this link. Okay, remember that you can do that also with your own ROS jet. So then I'm going to copy this link and then I'm going to put it into the emission here onto the chat that I have for the emission. And you have to click on that link, and by clicking on the link you will get this ROS jet on your own area of the ROS Development Studio. Okay, so you will have here your own user, and then you will have this copy. You will not have those ROS jets that we have here, because those are the ones that I have prepared, my colleagues, we have prepared for different purposes. But you will have this copy of that ROS jet. Then once you have the copy, once you have followed the process of clicking on the link, then if you don't have an account on the ROS Development Studio, it will ask you to create one. No problem, just create a free one. The easiest one is going to work because it's the same as I am using here with this live class. Then let's go to open. Once you have, click on open, and then again on open on the second screen that appears. So the ROS jet is going to start. Okay, so far so good. So I'm showing you there what is happening. Let me configure this in another way so it doesn't disturb the options. So I can see what is happening on the emission, and it's not disturbing what you see about the loading of the ROS Development Studio. Okay, then let's continue. So remember, guys, if you have followed those steps, you should be in a screen very similar to mine. But if you have any question, put it on the chat. So between Christian and myself, we'll be answering your questions, and we want you to leave this class with more knowledge than the one that you entered this live class about ROS. Okay, so it's our purpose to make you learn about ROS, to make you learn about the subject that we are doing today. And for that, in case that you get stuck, you don't understand something, ask us the questions there. Okay, so please do not hesitate to ask us a question. Then in my case, it has already started the project, and then I'm going to say no. Oh, okay, so I click there and then it disappeared. No problem. What happened if I don't have the ROS jet here and anything, so I don't have anything? Okay, so if that is your case, then go to tools in order to open the notebook. Okay, go to tools, to the menu here, tools, then select Jupyter Notebook. And then the notebook for this ROS jet should appear automatically. Well, you will have to click on this one, okay? So this is for selecting in case that you have more than one notebook. In this ROS jet, we only have one. So we click on here, and then it opens. So in the last modification that we have done, the notebook is opening in a new tab. I don't think that this is very convenient because it's kind of confusing one thing and the other. So then I don't like this new behavior. So let me know what you think about clicking there and opening on a new tab. I think it's better if we have it here and as an option, just as an option, but not by default. Well, let me know what you think. That's not important for today. So if you have the notebook open there, it's okay. If you have the notebook open here in another tab of the browser, that's also okay. Okay, so let me check quickly if there is any problem in the chat. Let me see. I don't see any question there. By the way, before I start with that, let me show you on the camera that I am having my coffee with my ROS2 mug. You know, this is a mug that was delivered to me by Professor Chang from China when I visited him on the ROS summer school that he organized last July. So that's Thank you very much, Professor Chang, for this. So let me have some coffee. Then let's continue. So you are okay, so you are following, you are not missing anything. And then Gloria is indicated that she still is not on the ROS yet, probably because it takes some times to load at the beginning. So yes, so do not worry. Then I'm going to start explaining this, but you don't need to be here because you don't need to be doing anything. So what is this class? As I mentioned, it's about trying to find where is the error when you have a robot arm that is not moving. So you have created your simulation or your controllers, you have configured everything for making the robot properly working, but it doesn't work. Or somebody provides you with a package that says, this is going to work. So it's working for me. But then you try and it doesn't work for you, especially in the part of the controllers. I'm talking about the part of the controllers, that the robot doesn't move. Then how can we debug all that? How can we do it so we can find where is the error? Okay, so for this class, you need to have the basics of Linux knowledge. And in case that you don't, I have put here a free online course that you can take. Also, you need to know about ROS basics. I have included here also, those are courses that we do at our academy. And we recommend you that you do it because they are very nicely done. Of course, we have done it. What can I say? Yeah, what can I say of my own child, you know? So, you know, but it's true. So they are very nice. And also you need to learn about ROS control. And you need to know at least some basics about ROS control. And finally, the final requirement is love for robotics and a little bit of patience. Yes, that's it. So let's go and let's try to detect. And everything here is packaged in what we call a ROSject. If you want to know about more how to create your own ROSjects and what it there, how can you use for your own classes, courses, research, just check this information there. So now let's go. Today we are going to use this arm robot. And let's do one thing. Let's start by launching the simulation and see what happens. Yeah, so we want to control this simulated robot here. We want to figure out why it's not working. So let's launch a simulation and we are going to see that it doesn't show very well. So how do we launch the simulation? We go to the simulations menu and select choose launch file. So let me show you. It's here on the ROS Development Studio. You go to simulations, select choose launch file, and then in this box that appears here, you have to click on this pop-up menu or drop-down menu, and then go down into the list until you find the Cortex Gazebo package, then select the main launch file. Select that one and then press launch. By doing this, then a new window is going to appear here that is going to show our simulation. And let me see if you are ready. Then Gloria says that she's in. Yeah, okay. I presume only Gloria says, but I presume that more people is also in, I hope. And then let's see what else. So here it's loading the simulation. It's starting. Let's see if it shows in a few seconds. Once we see the simulation, then we'll be able to see what is happening with the robot. So simulation is running, says here. So it's a matter of time to see the simulation loading here. Come on guys. Come on guys. Show me the simulation. Okay, in the meantime, let's move with the other problems that we have here. So here you have the instructions in the notebook, and then what we should see is something like this, like a simulation like this. Then let me see if it's not showing. Okay, so it says that simulation is running, so it looks like it's a problem on the speed here of the screen. So it looks like it's taking some time. Maybe it's because my transmission, by the way, I'm transmitting 1080p as requested by, what's the name there is one of the our followers that is always requesting 1080p, and then finally I achieved to manage. So I presume that you are watching this in 1080p. Well, so that's a lot of information to be transferred. So here we have the simulation, and yeah, as you can see, the robot is kind of crashed into the ground, and it could be collapsed in many different ways for you. It's random because the controllers are not working at all. So what are we going to do? Then let's follow with the instructions. So when this happens, then there is a test here that we can do, but we are going to skip until the end. This test is about making the robot move following a trajectory, but I can tell you that it's not working. So it's not working, so let's see what is actually happening. Okay, so the first thing that we have to do is that why is this not working, and what is what is actually the problem that we are trying to fix? Well, we haven't constructed this from the very beginning, so we think that everything is or should be already working. So we are making some assumptions in the situation that we are having. So the first thing is that we think that we have the robot simulation, it's working properly. That's what we thought before we launch it. Then we also think that we have made the controller's configuration, we have created that configuration properly and correctly. And also we think that when we launched the simulation, everything tried to load the controllers. So that's what the assumption that we are getting there. So when we get into this situation, we think, oh, I think that my simulation was correct, that I configured properly the controllers, that I have launched and loaded all the controllers properly, but the result is this, is not good. So based on this situation, how can we find where is the error if we think that we have done everything properly? So that's it. So let's try to find where is the error. First, I have included here one image about the ROS control. So it's necessary that you understand a little bit, just a little bit of this part, at least until the yellow part. So this side here and this other yellow part there, that is how it works. ROS control for joints and robots like this that have joints. So basically we have a controller manager who is the one in charge of loading the controllers for the different elements that we have in our robot. So we have one element that is called the controller manager. This is the one in charge of getting those controller plugins ready and started and paused. And then we have the controllers themselves. The controllers are the ones that, when loaded by the controller manager and when executed by the controller manager, they will apply to one joint of the robot. And they follow in this area here, but we are not going to deal with this. This is too much complicated for today. Don't worry about that. We don't need to know about this for this problem here. So we think that we are loading the controller manager properly. We think that the controller manager is loading properly the controllers, and we think that the controllers are properly configured. That's what we think, but the result is that this doesn't work. Okay, so let's go and let's check what could be the problem. The first problem that I found always that I am dealing with these kind of problems is that there are some controller packages missing. So the Linux system in which we are launching this doesn't contain all the ROS controllers, ROS packages that contain the controllers for this robot. That's the first one. So this is the first thing that you should check in your system. Then you need to have 3 types of packages. I have divided into 3 types. The first one are the ones related to ROS control. ROS control are the core structure that provides this system as a whole. Those are the packages that allow you to use this structure here for controlling your robot. Okay, so you have to check if those are installed. And how do you do? Well, by using these commands, sudo apt install ROS kinetic. But in our case, if you do that and then try to install one of those, one of the list of this list, then you will see that have been installed. So we can copy this command sudo apt install up to here, and then try to control copy, then come here. Then let's open a terminal. Let's open a shell here. How do we open a shell? Go into tools and then select shell. So then we have this terminal here, and then we can launch this command that is called sudo apt-get install. Then we have to include ROS-install and then one of the names of the packages. That's, for example, ROS control. So let's type here ROS control. Okay, so I typed wrongly the command. Like this. Oh, yeah, type wrongly. Instead of install, sorry, it's kinetic. You have to indicate here the name of the distribution. Okay, so here it says that this 0 upgraded because it's already installed. It's already installed and the newest version. So if you keep doing this with all the others, you will see that it says the same thing. So all of them are installed in our system. Then second thing that you have to check are the controllers packages themselves. So those packages are related to the structure of ROS control, and those packages here are related to packages that provide several types of controllers of this yellow ones that are already done for you, so you can use it. You don't have to create your own one. So you will do the same thing. The only thing is that you have to change in here. For example, let's say the effort controllers. Okay, we have here the package effort controllers. Let me select here. So effort controllers. Then if you want to check if this package is included, you have to do the same thing here. There are other commands, okay, for checking on the cache and so on, but I'm showing you the easiest one. Then, for me at least, is effort controllers. So here, effort controllers, and also says that it's already the newest version. So check here the command that I have here, that I have included at the beginning ROS kinetic and then hyphen, then the name of the package of the controller. It always follows the same structure. So if you want to check for any of the other packages, forward gripper, you have to include first, before that, ROS-kinetic, and substitute the underscores of the name by hyphens. So for example, for the effort controllers, you see here that there is an underscore, and then I have substitute here. When I check the package, I substitute the underscore by a hyphen there. Okay, so that's the first check that you have to do. Let me see if there is any question, any problem. Then Matthew says that it doesn't tell us to source it. What do you mean? Matthew, I don't understand your comment. Their compute says, I unfortunately only can watch your stream now. We'll go through the ROSjet later. Okay, no problem, no problem. You can watch, you can do whatever you want. This is for you, for your learning. I recommend you that you practice, okay, as soon as possible, because otherwise you are going to lose the knowledge. Then it says, Nahib says, where can I get the Word document? Their compute is answering. Then Gianfranco has arrived. Okay, Gianfranco, welcome to arrive finally. Very good. You are also coming most of the live classes, but today you are late, so you have to go to the back of the class there, sit there a little bit further from the screen and get the ROS that is on top of this chat. And then Matthew says it doesn't tell us to source. You don't have to source anything here because it's already sourced. So the terminal that you open, it's already sourcing everything, especially the place that you are mentioning, because everything has been compiled, everything has been sourced, and then the terminal is already configured in the bash RC to source everything. So you don't need to. Okay, so let's continue now. Then the other thing that you need to check is that the Gazebo controllers, in case that you are using a simulation, like it's our case. So you have to check that those packages have been installed. Gazebo ROS and Gazebo ROS control, both of them. So they have been, and then so we are not going to do anything else. So that check is correct for us. So okay, so but the robot is still bad. So what can it be? Let's see. Let's check another thing, another way of checking. So check here that we have numerated the different checks by numbers. So that's check number 2. So let's see if the controller manager has been launched. Remember here that we need to have this controller manager, that is the one that is going to allow us to load those controllers. So let's check if the controller manager is launched. For that, we are going to launch this command. It's called ROS service list. So when the controller manager has been launched, then it will provide a service. Actually, it provides several services, as you can see here on the picture. So let's issue this command, that is, give me the list of services of ROS, but filter and show me on the screen only the ones that contain controller manager word. That's a command. Okay, so let's copy this command and type it here on the terminal. I'm going to make a little bit larger the terminal so you can see better and more information. So paste it here, and there it goes. Nothing, but it should say like this. Okay, so we don't have, so we have figured out one first problem. Okay, the controller manager is not getting loaded, but I thought it was, because my friend gave me this package, and then he was saying that it was working. So what is happening here? Let's see. Need some coffee. Okay, then let's see if so that's the meaning of the problem. So what we are going to do is to check what is happening, why the controller manager it's not loading. And then there are two possibilities. If we are working on the real robot, the controller manager should be loaded during the bring up process, when you load your systems for your robot. So it should be done there. I cannot give you a complete example now because we don't have the robot, so we cannot practice, but you should check your bring up launch file, and it should be there. So if it is not launched, the problem is there. Then as a Gazebo, we are using a simulation, then the problem, it has to be in the loading of the Gazebo plugin for ROS control. So remember that we have installed here a Gazebo ROS control package. So this provides a plugin for creating a controller manager inside Gazebo. Then this plugin has not been loaded for whatever the reason. So why? Because we have touched this file and then removed the load of the plugin just to make funnier the exercise, of course. So let's go to the Gazebo definition, to the URDF definition of the simulation of the robot, and let's figure out the place where the robot should be loading this controller manager. Then for that, it's on this file that is called Cortex robot.chacro. Chacro and URDF are the formats used to define the robot structure. So let's find this file and see where is the problem. Let's go to ROS.ds. Then here we need to go to the files that define these simulations. So for this, let's go to Tools and select IDE. by using the IDE, you are going to be able to see all the files that this ROSjet contains. So for example, the files of the notebook are included here. The files of the simulation are included here in the source. And any program that we need is going to be included here, not in this calculating workspace. Today, we don't need this. So here we need to check on the simulation. So here the simulation workspace, source, ROS Cortex, open this one, and then let's go to the Cortex description here. Usually the package called description is the one that contains the URDF definition. So let's go to the arms, and then I think it's here in URDF. No, it's not that here. So then it's here in robots. Sorry, I didn't write it there in the document, and then I don't remember where it was. It depends on the organization of the simulation. So depends on the every creator of the package for the simulation. Okay, so here in the robots, we got this package that is Cortex Robot Chakro. Let's open, double click, and then, yeah, we got it there. So here we have the URDF description, URDF Chakro description of the robot, of the structure of the robot. This is used by the simulation to represent the robot in the simulation screen. And then here, if you move to the bottom of this file, you will see that there is this part for Gazebo that it's about loading the Gazebo ROS control. Okay, so that's commented. As you can see, it's not being launched. So here is the problem. This is to simulate the case that you forgot to include this Gazebo part in your URDF. Okay, so let's remove the comments. Remember to remove the comment on the top and then the part of the comment on the bottom, because this is XML and then contains both things. Okay, let me put it back again so you can see what I have deleted. So the comment has this part here and this part here. So remove that and remove that. So then you can see that the code changes color, indicating that this is now activated. This is now taken into account. It's not a comment anymore. So I put these comments there just to simulate the case that you forgot to include the ROS control. So if you forgot this, then you will not have the problem. Okay, so this is done. We have changed this. Then let's launch again. Let's continue. Let's go to simulations again, and then press the button change simulation. Then choose select launch file. You already know, and then the already selected is okay. So press launch. Then we got here again the screen, and let's hope that this time is going to work. In the meantime, that is loading. Let me check people on the chat if it is working or not. If you have any question, how is it going? Then let me see. So Christian here is answering some questions. Great. Then Kaula Pico, can you install Anaconda the way automatically have Jupyter Notebook? Okay. Yes, that's for an local computer. You can do it. Here in this case it's already installed. Then we have here nothing more. So some people talking there. So let's continue then. Okay, so here we have the simulation, but still the robot is like this, so it's not showing properly. What can it be? I don't know. I have no idea. And then it disappeared. Yes, definitely there are some problems in the connection here, and it's very likely that it's due to the fact of the 1080p's. So it's reloading. Let me reload it. Let me force the reloading. By pressing this icon here, you can force the reloading, and so in order to see better the simulation. There it is. Okay, so it's loading. Great, but it's not showing. So what is happening? So once we have done this change, let's check again if the controller manager is being loaded. So let's go to the terminal and let's issue the same the same command. Hey, this time we got a different answer. Now the controller manager has been loaded. Okay, so it's loading. Then let's check now if the controller manager has actually loaded any controller. So remember here in the term, let me go back to the image of the ROS control. So now we have this system in blue working, but we don't know if there are any controllers there that have been loaded for controlling the joints. Okay, so let's go to the next step, is to check if it's here, to check if we have any controller loading. For that, we are going to use this command. It's to call another service that is provided by the controller manager. It's called the list controllers. List controllers is going to give us the list of controllers that this blue thing has loaded in the inside. Okay, so let's issue this. Because the service is ready, we can issue this command here on the terminal. I'm calling a ROS service of the controller manager that is called list controllers. And we see here that the list of controllers is empty. Okay, so now we know why robotics like this. It's because there are no controllers loaded. But why there are no controllers loaded? I put this on the URDF of my robot. Actually, not on the URDF. This is on the launch file. The one that indicates which controllers to load. So let's check where is the problem. And what we are going to do is to follow all the launch files that are working when we activate the main.launch file. Okay, so remember that in order to launch this simulation, we are launching the main.launch file. So let's follow that and let's see at which point the controllers should be loaded, but they are not. That is why you needed to get some knowledge of ROS control in order to follow this class. But don't worry. So I'm going with you step by step and I'm guiding you. So for now, we have to go to the package that is called Cortex Gazebo. Remember that the main.launch, let me close this one, so we simplify here. We were launching a main.launch file included inside Cortex Gazebo. So let's open Cortex Gazebo, then go to launch, and then here it is, the main launch. Let's open it. Then this main launch is launching two other files. The start wall, that is just for the environment of the simulation, and then the put wall in robot in wall. That means put a robot in the wall. That means put the arm robot there. So let's check that second one. Then we open the second one that is here just beneath the main.launch. So I'm opening it, and here is doing some configuration with parameters. And then what it does here at some point in time is to call this other launch file called spawn cortex robot.launch, and that configuration there. Okay, let's open that other one because here I cannot see anything related to the ROS controllers. So let's go here to spawn cortex robot. Let's open it, which is here beneath. And then here we have a lot of stuff, more stuff. Okay, so here it looks like we are doing something. Okay, so in order to load the controllers, you need to do two things. First one, you need to load the controller's configuration into the param server. The controller's configuration is included into a config file, into a YAM file. I'm not going to explain you about that because too many things, but there is a YAM file that explains that, how to configure the controllers. And we should be loading that file at some point in time here. So let's check where it is. And it is here on line 75, where it's loading the controller configuration. You see that it's loading two files, but actually it's only loading the second one in case that we have selected the gripper. And that's correct. We want the gripper, so it's loading both of them. So here we have the file that defines the controllers, and this is being loaded, so it looks like it's correct here. Oh, I made some mistake there. Okay, done, solved. So it's looking that it's correct. So it's loading this one, it's also loading. So first step looks correct, at least right now. So we should check this file later and see if everything is correct. But so for now, we are going to hope that this is correct. Then next thing is that we should load the controller that is defined in that YAML file. So we should call the ControllerManager spawner. And this is done here. You can see it's called the ControllerManager spawner in order to load the controllers that we are specifying here in the args. But so here it looks like we are calling it, so it's there. But the problem is that it's not correct, because this is the ControllerManager spawner that is used in case that we don't use a gripper. Why? Because this if condition. But this has been selected in previous launch files. If you follow for it, it is included here. Okay, so this argument name here is indicating that we are going to use this gripper. So this spawner is not going to be used. Then here we have the second spawner in case that we use a gripper, and as you can see, this also commented. That is why the controllers are not getting loaded. So what do? Then we are going to remove the comment from this side only, this side here, remove that, and now put this comment here on the where it says with gripper. Okay, so it's hyphen greater than. Then now you see that it has changed the color. That means that this is now taken into account. So now this is the one that is going to be called to spawn in order to load those controllers that we have in the args. Okay, so let's try again. Let's go. So we have done another step. Let's try again to launch the simulation and see if this time it's already correct. So go to simulations menu, then press change simulation, then choose launch file, then just launch because it's the proper configuration. Let's hope that this time is the correct one. This time, yes, almost there, guys. Let me see, anything that, let me see, so here, that says, let me see, is Electrobot says, please make a video on how to set the inertia parameters in Gazebo. Which software to use to find the parameters? Yeah, that's a very good one. We tried to do that once, and that was a lot of work. We usually do this by trial and error. If the robot is complex. Okay, for simple things it's very easy. We usually take the basic shapes like cylinders and squares and so on, and then we use those as close enough to the reality, and then we check if it is correct. If you require more precision, then we use other programs, and I don't remember now the name. What's the name? It's a Linux tool. I don't remember now, but then that system works sometimes and sometimes doesn't. So it's complex. It's a very good point. It's a very good point. Then Gloria says that his resolution is very low. Setting, okay, it should be in 1080p, and definitely it's going to be recorded like this by YouTube, so you should be able to watch it later in case that you have some problems now with the connection. Okay, so now we have this here, but still we don't have the robot here moving. What is happening with this robot? I don't know. Let's go and let's repeat the process, the steps that we did before. So first, let's check if there is the ControllerManager. So I'm going to repeat the command here to check for the ControllerManager running. There it is. Now, let me see the list of controllers that have been loaded by the ControllerManager, if any. Okay, wait, we have something here. So we have the joint state controller that has been loaded and the robotic 2F whatever gripper controller. So we have the joint state controller and the gripper controller, but not the arm. So those are two different controllers. The second one is only for the gripper, that is the black thing over there. There you can see there. Yeah. So that thing is a gripper. And then the other one is for getting the state of the joints. It's like a plugin. It's not going to do any control at present. It's just for knowing. So, but we don't have the main one of the arm. So let's check the notebook what it says now. So all these things that you can see here on the notebook are the ones that I have already explained to you, and where we found the error. Okay, so yeah, so we are here on this point here. We have checked this and still we get this problem. So what we are going to do now is to check here of the comments. Let me see here if we see on the comments here of the comments of the loading if there is any error. So we have here action client not connected. Well, that could be an error due to the controller not being loaded. So let's see on top there is another one, loading controller, no P gain. Okay, so here you can see that says no P gain specified for PID finger points. Okay, don't worry about that. That's an error, but it's not important error. It's not important one. So actually, maybe it's not even an error, but this is indicated as an error. So don't worry about that. The problem is here that it says could not load controller Gen 3 joint trajectory controller because controller type F4 controllers joints trajectory controller doesn't exist. Okay, when you get this message, this usually means two things. One, you haven't installed the packages that contains this controller, or second, you have an error misspelling this. So there should be an error in the place in the configuration file where we have indicated to load this controller. There is an error in typing. So why I know that? Because I know that this controller package is being loaded because we checked that at the beginning of this class. So there should be an error here. So let's go and see on which file this is specified. Where are we indicating to load this? Okay, so this is indicated in this file. Let me go back here. When we load the controller's data configuration. So remember, it's in this place here. So the file that we have to check is this one, joint position controllers.yum. And this is included inside the Cortex control package, arms, then the name of the arm, and then config. Okay, so let's go here. We have it, all the packages here. Cortex control, then arms, then Gen 3, because it says, yeah, Gen 3, and then config. And then here we have the YAM file. So let's open. And here is the list of all the controllers that should be loaded. And in this case, the one that is failing from the message is this one. You see, this type doesn't exist. This means that the error is here in the type name. And I can tell you, so you should go now to the documentation, check the F4 controllers, and find that this message doesn't exist. This type of controller message doesn't exist. Why? Because there is an S here that doesn't belong. So it says joint trajectory controller, and it is joint without the S. So let's remove this S. That's it. And now everything is changed. So everything is properly done. Now this joint trajectory controller is going to work. So let's go back and let's try again on the simulations. Change simulation, choose launch file, launch, and let's see if this time is the proper one. Let's see, guys. I think I have something in my heart says that this is the correct one. This is the one. You'll see. Any questions? Are you following? Did I jump too much? Let me know. And my coffee is finished. I think I need a bigger mug with more coffee. CSR2R says yep. Matthew says following. Perfect. So okay, so CS2R means yep, that you are following. Great. Great, guys. Very good. Very good. We are almost there. Almost there. Almost there. Let's see. It is loading. It is taking some time. When this happens, usually it's not a good point. Usually it's not very good. So joint trajectory controller says it's not. Let me check here if it is loading. Did I make any mistake, or so it's taking some time? It says loading, but no messages here. That's very strange. That is very, very strange. So I don't know. Okay, so it looks like there is a problem. Let me check if there is any problem here that I'm missing. So here is what I have explained to you. This is the joint trajectory controller change that we have done. And then, yeah, so we should get it. We should get it. So let me see if I have messed this up. And what I'm going to do is just to close this one and relaunch again. So go to simulations, choose launch file, main.launch, and launch. Then in the meantime, let me check if I have done any mistake. I'm very prone to do that usually. So let me check that here I haven't changed anything without knowing. And let me see, it looks correct. Here also I didn't change anything. Then let me see. Yeah, it looks correct. Everything. Yeah, no problem. So let me see here if this time it has loaded. No. So it has a problem. It does a problem. And then for some reason we don't get the messages here that should help us to debug what is the problem. Okay, so now it's time for more complex things and figure out what is the problem. I can tell you that this was not planned, okay? So I don't know what is happening here. Let's try to figure out. So first of all, I'm going to go to the terminal, and then first I'm going to close this simulation. So everything related to Gazebo is going to be killed. Yes, so now we don't have any other process of Gazebo around there running. So I'm going to be sure by doing ps fox and see that there is nothing in here related to simulation. Okay, so then do a ROS launch. Let's execute manually the simulation. So let's see if we can see what is happening with this simulation by launching it manually, because the messages were not appearing there anymore, so I don't know what is happening. So do ROS launch, then Cortex _ Gazebo, then main.launch. This is the launch file that we are launching with the menu. It is supposed to be easier, but and then here it says ROS launch. Okay, so it's not executing. Let me see what is detecting. Gazebo, yeah, that's correct. It says, okay, file doesn't exist. So, okay, I can see this this config. Oh, I did some mess here probably by maybe I moved something here. Let me see. It's on the arm config. Okay, arms Gen 3 config. Yeah, it should exist. It's here. Okay, then let me see here on the IDE, on the launch file, what is happening here on the loading. Not that one. Put robot in the, no, it's that one. Spawn Cortex here, loading the, oh yeah, I can see where is the problem here. For some reason I have deleted, I don't know. I deleted that one. So what is saying here, the message is that it cannot find the rest of the file, of the config file. That is why. Okay, so I don't know what I did here on the keyboard, but I removed the file. So let me write it down again. So joint position controllers.yum. Okay, so there it is. And now let's launch it again. So now it should work. Okay, so that was the problem that I missed this keyboard that we have here. This is a touch screen, and then I have removed something from the screen, and probably I did it by touching the screen. Okay, so now let's go to tools, because when you launch a simulation from here, from the terminal, then the Gazebo window doesn't open automatically. You have to go to tools and select Gazebo image, and then it looks like everything has been loaded. So there it is. Well, not it is yet, but it's simulation running. So when this says here, that means that everything is running, and now we are waiting for the visualization here. I hope. Let me see if there was any other problem here. Okay, we have here some problem. This error, don't worry about that. So that's something different. It's something else that we couldn't solve it for this class, but it's not interfering with the simulation. So don't worry about that. The same way as the no P. And here I think that we have already the, yes, we got it. Okay, great. Great, so we have it. Yes, as I mentioned, those two errors, don't worry about them. We'll figure out in some other, in the future, how to solve them. But don't worry about this. Then, yeah, we have the system ready for launching and for making it run. So what is happening here? Let me refresh. Let me refresh the window. And let me know if you are having this system working also. If it is working for you. Then we have, it's quite difficult to follow and feed my daughter at the same time, says their compute. Sorry, their compute for this. Sorry. Then Mechatronica Maxima. Oh yeah, it was you, the one who requested that 1080p's. Okay, so he says, it's okay until now. Gloria Feliz, I have been tuning in and paying attention to the lesson. I am sharing this with my Express team. So when we get to this point, ARM doesn't work, we will be reference this training. Okay, great. Great, thank you, Gloria. Mechatronica Maxima says it worked for him. And yes, Gloria, he's asking excellent ROS troubleshooting. Great. Matthew says not working. Peter says thank you, work for me. Okay, and in my case it's not showing here. It's taking like a long time to load everything in the visualization. Then I'm going with you, okay, Matthew? Just a second. Let me see if we can do. So Matthew, can you express what is happening to you? So what are you obtaining? What is the result? In my case, it's not showing, but everything is running. So because of this check. So let me reload again. Let me reload. And let's see if now it loads. Let me see if it loads. If not, then I don't know. It's very strange because it should say here like a lot of CPU, and it's doing kind of bursts. So I know that it should work, so but it's not showing here. Okay, so I'm going to close this window. I'm going to close it. I'm going to close here also, and I'm going to launch it again. So I'm killing it. In order to kill this program, you have to be sure that you have the focus, this tilting prompt, and then press Ctrl+C. And then it takes some time. Takes some time. No, don't desperate. I desperate and then I press a lot of Ctrl+Cs like this, you see. But don't worry. So now let me launch it again. ROS launch Cortex Gazebo main launch. There it goes. And let me open in Tools the Gazebo window. So we should see here changing from no simulation running to simulation running. There it goes. Now everything running here. The two problems that we mentioned, you can start planning. This is the message from Move It. So we should be able now to move it. There it goes, my robot, in my case, on my screen. And now, let me see if Matthew has finally got his system. Then it is limp like it was before. Okay, Matthew, I don't understand your problem. Give me more details. I would like to help you. Then Bored says, awesome. Yes, this is awesome. We are about to finish. Okay, guys? So stay with me for a few minutes. Matthew, I'm still with you. I'm not leaving you behind. Let me know what is the problem. At which step did you got stuck? And what is the messages that you are getting? Put it there on the chat. Then for the rest of you, let's do the final test. Let's check that the robot can actually move using Move It, because now everything is running. So I have included here a message, a command for using a test, using Move It. Just copy that one, select and copy, and then go to the ROS Development Studio. We need another terminal because we have been using this one for launching. So go to Tools, select Shell again. So we have another terminal. And here, when it shows the prompt, then Ctrl+B to paste and launch it. By doing this, the robot should start moving, doing some tests. It's just a basic test to check that everything is working. And there it goes, there it goes. It takes some time, it's loading a lot of stuff. Take into account that our system here is running a lot of stuff. It's only using 2 CPUs. I'm using only the 2 CPUs at course as you. So, but you can see that everything is working. We can do a lot of things with these 2 CPUs. There it goes, there it goes, there it goes. The robot is moving there. Okay, guys, we got it. We got it. We have been having this moving and working. Let's see if Matthew or somebody else has also problems. Then Matthew says, it's doing the same things as it was when we started. And then if you have this problem, then it means that some of the steps were missing. So you missed some of the steps, because as you can see on the video, then we have been covering all the steps, and you have the same stuff as I have, the same project. So Matthew, let's do one thing, because it's already late. Then let's so please try to do it again, reviewing the video. So when we finish this transmission, the video is going to be published in our channel. So you have the project, you can go the video step by step and stop. And then in case that still doesn't work for you, please give me a comment there on the video, and then I will help you on debugging this. In case that you don't, maybe we can even have a live chat together and figure out, because it has to work. I mean, so I'm sure that in one of the steps, when you were switching between one screen and the video and the transmission and the ROS-DS, then you got this. It says Cation client not connected. Cation, that's very strange message. Cation client not connected. I don't know if I'm following. Action client not connected. Okay, yeah, the action client not connected, sometimes it happens, but then it reconnects. If everything is correct, then it reconnects. So you can have this message over here. Sometimes, in my case it didn't happen now, but sometimes it does happen. Then it has a system that it tries to reconnect all the time until it gets a connection. So I don't think that this is a problem, Matthew. Okay, so let's do that. Okay, Matthew? Then I would like to review then your case. So guys, we are going to finish here today. Just let me tell you one thing more that you may be interested, is that we have started a weekly contest about finding errors. So if you stay tuned to our channels like Twitter or our YouTube channel or so, you are going to see that we are going to announce right today the first of the weekly contest. Every week we are going to do a contest where we are going to publish a project. So you will copy a project, and then you will have to figure out what is the error in the project in the same way as we have done here for these controllers errors. Then you will have to figure out what is the ROS problem in that project. Why the robot is not moving, why the robot is not creating the map, why the robot is not detecting. So you will have to figure out by yourselves what is the problem. And the first 3 ones that find the error and then post it in Twitter, then will get a ROS Developers t-shirt. I am a ROS Developer t-shirt that we are going to send to you. So please stay tuned to our Twitter, especially where we are going to announce this. Also in other ROS channels. So you will be, if you are tuned to ROS, you are going to get it. And it's going to be a weekly contest. So that's it. And then in case that you need some extra information, you need to learn more about ROS, please go to our academy. It's called the Robotic Night Academy. We have many courses like the ones that you have here to learn more about ROS control, TF, ROS perception, ROS basics, with Python, with C++, etc. Have a look at there. And that is all for today. Let me switch back to the camera and show you that I am already done with my coffee. So yeah, no coffee here. That's done. No, yes, finished. Yeah, just to let you know, that's my situation in life right now. And then, yeah, I would like to answer some questions in case that you have. So we have some minutes yet there. So please put your questions on the chat. Then Matthew, I can see on the chat that Matthew has indicated that he will go through the video again. So Matthew, I think that this is the way, because you have missed one of the steps in that case, and then that's a problem. Then maybe at the beginning or maybe at the end. So we should see very clearly which one is the one that you missed. The Mechatronica says a tutorial to review how Moveit works here. Yes, yes. So by the way, we are working with the Moveit company that is behind Moveit, that is called Picnic, and there is going to be on the 20th of November, there's going to be the Moveit Day around the world, and then we are preparing a free webinar for teaching about Moveit, the basics of Moveit, in the day before. So that will be the 19th of November. So I will let you know, okay? I will put something once this is completely set up. This is not 100% sure yet, but almost. So I will confirm this through the community here in YouTube. Then what else? Gloria says, cool, great contest, more ROS troubleshooting. Yes, that I know, Gloria, you were going to like it. Yeah, you want the t-shirt? Yes. Robotics says, super cool. Yes, it is. And yeah, so if you are not a Twitter person, then start getting something there. And Matthew agrees that something small step missed. Great. So check it out, please. Matthew, I'm with you. Okay, so let me know if you don't get it. And then maybe we can arrange a personal communication even and solve it. Then Ashit says, when can we expect control of robotic arm using ROS 2 and Moveit 2? Okay, that's a very good point. And I think that we should wait until January of 2020, until January, not program in the next 2 months, in November and December. Now that we have the program already covered there. Sorry for that. And it's also in very early stage also, Moveit 2 and ROS 2. So Robotics says, what would be the next live class? The next live class, we are going to show you how you can create your own project. So you've seen in all those live classes that I have shared those projects that we have created. We share with you so you use it. But what about if you want to create your own and you want to share with your students, with your fellows on the same research center? What if you want to publish this into your web page to show that you have something working? What if? So that's what we are going to do on the next live class. I'm going to teach you, and we, all of us, we are going to create the same project step by step. Then Hack says, know of any tutorials for making your own controller? Yes, we did one live class about how to create your own controller. So check it on YouTube. I think that's the first one that comes to my mind. Otherwise, you can go to the ROS control in ROS Wiki, and then you will find some information there. It's a little bit dry, but you can get it. Otherwise, I recommend you to watch this live class that we did it some months ago about how to create your own ROS control. Then Der Caput says, thank you. Yeah, thank you. You like the way to teach. Thank you, Der Caput. Thank you very much. It's my pleasure, really. Really, I want you to learn. I want you to learn, really. So I take as much care as I can for you to learn. I'm giving my best. So that's it. Then Gloria says, I want to learn how to make my own ROS jet. Yes, thank you. Okay, great, Gloria, thank you. Robotics says, is ROS DS works on Docker? Yes, it works on Docker. Gloria, I will ask my XPRIZE team, join that, how to make ROS jet class. Great, yes, tell to your friends, tell to your students, tell to your teachers, spread the word, and let's make a super huge class. Do you imagine if we have 200 people around the world doing the same live class, all of us? You will see. So that could be super amazing. We'll meet a lot of people there. You can talk between yourself and help, as I have seen that you have already done. So imagine if we were hundreds at the same time from everywhere in the world. That would be amazing. So one day we'll reach that. But I need your help on that. Okay, so spread the word, guys. Then she says, thank you, you wait until January. Okay, we'll do our best for that. Matthew, thanks. Gianfranco, thank you. Ricardo, thank you, Gianfranco, for coming as always. CS2R says many thanks. Thank you, guys. Thank you. And then, yeah, everyone should learn how to make a ROS jet. yes. Thank you, Gloria. And then Treshagurewe says, you plan any lessons like how to do real arm catch items using the camera? Wow, that's we don't plan to do that. That's very difficult. I mean, that's a lot of work. In 1 hour is too much. Maybe for a whole day webinar, maybe we can think about that, doing a whole day webinar, trying to show that. Otherwise, it's too much. Robotics says, more people, more fun. Yes, and Peter says, thank you for the class. My pleasure, guys. Let's finish here. Already late as always. I don't know what happens. Always on the last minute, I got some unexpected errors and I have to solve them there live. But anyway, so that's all for today. Thank you very much, guys. See you on the next live class where we are going to learn a lot more about ROS and how to improve our level. Until then, keep pushing your ROS learning, guys. And then I hope I can terminate this. I don't know. Let me try again because I'm not sure if I'm going to terminate. I'm pressing this button and hope that